We've talked about dilations. We've talked about similar figures. Now we're going to talk about how to find scale factors if you have similar figures. So that's our goal for today. What's the scale factor between P and Q? All right. So first we start with this grapple of finding the scale factor. I just want to put a ratio or a fraction side a prime b prime. So that is 6 divided by AB. AB is 2. 6 divided by 2 is 3. Okay. Now let's look at b prime c prime. That is also 6 divided by bc is also 2. So 6 divided by 2, we're going to get 3 again. Now let's look at dc. dc, d prime c prime is 12 divided by dc is 4. 4. 3. What do you think the scale factor is? The scale factor is 3. This shape, if we went from ABC to A prime, B prime, C prime, was getting 3 times bigger. And we can see that by dividing the sides. Now, you might have been able to figure it out different ways, but these fractions are going to be really helpful for the rest of the unit. So we just want to get in the habit of using these fractions or ratios to figure it out. So let's look at the next question. So how would we figure out the scale factor of this dilation? Well, I'm seeing a bunch of numbers here. I just want to pick matching sides. So I see 3, D, and C prime, D prime, and 5. So my question is this 3 over 5 or 5 over 3? Well, A prime or ABC, the first shape, to get to the second shape, we want to get bigger. So this one would make us bigger, 5/3, because 5/3 is more than 1, right? That numerator is bigger than the denominator. 3 over 5 is less than 1. That would make the shape smaller. So if we were going the other way, if we were going from C to C prime the other way, then we would do 3 over 5. So 5/3 would be the scale factor on this one. You could also use 6 and 10, right? Those sides match. So 10 over 6. But notice if I do 10 over 6, oh, that would just simplify. I could divide the top and bottom by 2. So I would get 10 divided by 2 is 5. 6 divided by 2 is 2. So we would still get 5 over 2. Oh, 5 over 3, my bad. 5 over 3 if we divide those both by 2, right? It's the same scale factor. We just want to simplify. All right, so our notes for today. A scale factor. To find the scale factor when you have two figures is just make a ratio or a fraction. But you gotta choose corresponding sides. So I could use 15 and 6 together, but I cannot do 15 and 6.8 because those are different sides, right? This is the tall side of the 90, so this is the tall side. We want to make sure we pick the same or matching corresponding side. So I could use 8 divided by 3.2. If I was getting bigger, if I was getting smaller, I could do 3.2 over 8. So let's look at this example. I want to go quadrilateral P is similar to quadrilateral P is similar to quadrilateral Q. What is the scale factor that takes us from P to Q? All right, well, I see some matching sides here, the 4 and the 5. Now, if I'm going this way, I'm getting bigger. So I want to make sure the bigger number is on top, 5 over 4. So that is my scale factor. If I put 2.5 over 2, I could have used those matching sides, 2.5 divided by 2. It's 1.25. 5 divided by 4 is also 1.25. So either of those would have worked. We get the same thing. It's 1.25 as a decimal. All right, what is the scale factor that takes Q to P? If I went the other way, I'd be getting smaller. So I'd want the smaller number on top. So I could do 4 divided by 5. So it just depends which way you're going. Big idea here is if we want to get bigger, put the bigger number in the denominator or in the numerator, and then the smaller number on bottom. If we want to get smaller, put the smaller number on top and the bigger on the bottom. So that's just an easy way to remember which way you want to go. All right, try that cool down.